So you're here to learn about logs. No, not these logs. These logs. Let's begin with the basics. What is a log? Or rather, what is a logarithm? Similar to how subtraction is the opposite of addition and division is the opposite of multiplication, logs are the opposite of exponentials, and technically speaking, they undo them. For example, if we had, say, the exponent 2 to the power of 5 equaling 32, the log of this would be log base 2 of 32 is equal to 5. Logs can have different bases. For example, log base 10. When we have a base 10, we write just the log and then the number. We can also have log base e. In this case, this is what we call a natural log, and it's written as ln of the number. Now that we understand what a log is, let's go over some of the basic laws. Let's begin with addition. So, when we're adding two logs of the same base, we simply multiply the two numbers, so b and c. Log of 5 plus log of 6 is equal to log 5 times 6, which is equal to log 30. When we're doing subtraction, we do the same, but instead of multiplying, this time we divide the two numbers. So log 9 take away log 3 is equal to log 9 on 3, which is equal to log 3. Whenever you log a number with a power, the power can simply be put out the front. So, log 4 to the power of 3 is equal to 3 log 4. When you log a number with the same base, it always equals 1. So log 7 of 7 will equal 1, and log 10, we know that log on its own has a base of 10, will equal 1. Whenever you log the number 1, no matter the base, it will always equal 0. So log base 52 of 1 is equal to 0, and so is log base 10 of 1. Here are some problems. Pause the video here and have a go at them, and then come back and we'll solve them together. With our first one, remember that when we log a number with a power, we can bring the power out the front. So simply, it equals 3 log 77. Number 2, we have log base 22 of 22. The base and the number is equal. Therefore, this just equals 1. Question 3, log 6 plus log 7. Since it's an addition of two logs with the same base, we just multiply the two numbers. So, equals log 6 times 7, which is equal to log 42. Our next one is a subtraction. So, we go log 15 divided by 5, which is equal to log 3. Our final question here is log base 277 of 1, which we know that anything log 1 will always equal 0. Now that you understand logs, I know what you're thinking. How could this possibly be useful? Well, in the real world, we use logs to measure the strength of earthquakes, sound intensity, the acidity of solutions, and in medicine, logs are used in x-rays and when we're dealing with drugs. No matter the type of drug you take, the first thing you should check is the dosage. The dosage of drugs will vary between them as they are metabolized differently. Here is a table of some common drugs. As we can see, dosage and half-life are dependent on the drug. This relationship between dosage and half-life can be simplified into one half-life equation, where m is the amount left in milligrams, a is the initial in milligrams, k is a constant, and t is the time since consumption in hours. This is important as it allows us to measure the concentration of the drug in the patient's body without taking any extra measurements. For all drugs, there is a certain limit where if the concentration in the body is too high, it can become poisonous or even deadly. Let's have a go at applying this formula. A patient is given 1000 milligrams of paracetamol. After 2 hours, the concentration of paracetamol is found to be 500 milligrams. Determine the K value of paracetamol. Pause the video here if you'd like to try it yourself. So, we know our A value, we know our M value, we know T, and we're trying to work out K. So let's write our equation. So M equals A e to the power of negative k t. We sub our values in. 500 is equal to 1000 e negative k t. Sorry, not t. Negative k times 2. We start by moving the 1000 to the other side. So we get 500 on 1000 equaling e to the power of negative 2k, so it's easy to read. This can be simplified to 1/2 equals e to the power of negative 2k. Now we can apply natural logs to both sides of the equation. As we apply it to both sides of the equation is still the same. So ln 1/2 equals ln e negative 2k. As we know with our log laws, we can then take this power and put it out the front. So ln 1/2 is equal to negative 2k times ln e. Now we know that ln is really equal to log e. This means that the number that we're logging and the base is the same. So this cancels out and gives us 1. 1 times anything is itself. Therefore, ln 1/2 is equal to negative 2k. We can bring the 2 to the other side of the equation. Have ln 1/2 on negative 2, which is equal to k. And if we plug this into our calculator, we're going to get a k value of roughly 0.347. For this next question, we're simply trying to find m. And since we know our k value, we just have to plug everything in. So m equals a e to the power of negative kt, which is equal to 800 e negative 0.347 times 4, which is equal to 199.66 milligrams. We are able to graph the function with time on the x-axis and the concentration percentage on the y-axis. We can linearize the graph by having the y-axis as a logarithmic scale and keeping our x-axis the same. The logarithmic scale works by first going up in ones, then tens, then hundreds, and does this until infinity. It does the same going down, first starting with ones, then 0.1s, then 0.01s, so on and so forth. Here are some extra practice questions for you to have a go at. Pause the video, then come back for answers. Thank you for watching. I hope you now understand logs thoroughly and can see why they're so important in our lives. Don't forget to like and subscribe.